Hello, my name is Bonnie Burke, and I work for Workforce Resource. Thank you for attending today's workshop, and today's presentation is on quality tools and tips. No matter what job we work at, quality is extremely important. Manufacturing is actually my background, and in manufacturing, the key things that we measured was safety, quality, service, which was delivery, and productivity. And as you just heard, quality is the second most important part of a manufacturing process. So what I will be talking about today is I'll clearly give you some examples, and we'll talk about the importance of quality. I'll give you some information on quality terminology. We'll talk a little bit about tape measures and a little bit about calipers. And so hopefully in your handouts, you'll have some exercises and a note page that you can follow along and take notes. And also with your handouts, I hope you can practice using a tape measure on that as well. Now I understand not every job requires you to use a tape measure or caliper, but it's just two tools that oftentimes you'll see in manufacturing. Some of you probably can use a tape measure almost in your sleep, and some of you maybe have never used it before. So hopefully I can teach you a couple of new things. So quality terminology. On your handout, it talks about ISO. Well, what the heck is that? It's not is with an O. It stands for International Organization of Standards. If you've worked in manufacturing, you've understood or seen how some companies will work extremely hard to become ISO certified. The next terminology that I want to talk about is NCR. This really relates to quality. If a company would produce bad product and it got to the customer is going to send you a form called an NCR, or non-conforming report. They want you to tell them what went wrong and what are you going to do to fix it. Another quality term is actually a part of problem solving. And this term was actually designed by quality gurus, and it's DMAIC. Define, measure, analyze, and control. I teach a class on problem solving which introduces the lean principles, 5S, Kanban, and also formal problem solving steps. From my background in manufacturing, knowing how to solve problems using those tools was extremely helpful in several of our processes. The other term that I know this much about, but I wanted you to at least be aware of it, is called Six Sigma. It's a quality terminology process that was started by Motorola. Six Sigma defines that you can only have X amount of defects per million parts. Whoa, that's a lot to measure, per million. So if you want to learn more about Six Sigma, definitely look that one up on the internet. The other term that we talked about in our manufacturing series workshops is called HACCP, Hazard Analysis of Critical Control Points. HACCP is a requirement in any food manufacturing. And the last terminology on your workshop is SPC. It's called Statistical Process Control. Now, each one of the terminologies that I just mentioned, there can be an entire training program based around just that one term. So I wanted to give you a few quality terms that are very common in manufacturing, and hopefully if you've not heard of some of them, that you would look up on the internet or do some research about them after today's workshop. I wanted to show you a video that I found was an amazing example of quality in the workforce. And this video is from John Deere. I want you to listen to the pride in these employees' voices. I was so impressed when I found this video. I almost went out and bought a John Deere tractor. But I decided otherwise because I have a tiny little lawn and I live in town. Yet, hope you enjoy this video, and we'll talk about some of the high points after you watch it.
Quality here has been a long-standing tradition. Everything we do revolves around quality.
Started in 1837, John Deere was committed to quality. He always said that he would never put his name on anything that didn't have the best in it that was in him, and we definitely live by that.
I would not want to put a product out there that doesn't meet the expectation for the customer.
Quality is the same that goes in our golf product as our ag product.
Every line in this factory and every line in other factories throughout Deere follow the same enterprise quality manual. So we all have the same processes, the same forms, the same documents, the same reference material that we can use to solve our quality issues.
Once we come up with our design, we can actually go in off that design and do analysis.
We can see on computer if the design will meet the customer expectation initially, before we actually build a prototype. John Deere doesn't shortcut on testing. We do field testing, we do lab testing. We also take our prototype machines to customers to make sure it's doing what is expected to be done.
When we're defining a product, we bring manufacturing, weld-in, quality people. What are our existing issues? What are our existing problems?
We keep our assemblers in the loop throughout the whole process, from concept to out into production.
It's kind of rare to see in today's world. It's really a team-based program on the fairway mower line especially. Everybody has a great attitude. They work great together.
We use all the most advanced technology that we possibly can to ensure the best product for the customer.
Controller-operated torque tools, Bluetooth-connected hand torque tools,
Paperless work instructions,
banner vision systems,
RFID.
CMM is a coordinate measuring machine.
It ensures us that the parts that we have out on the floor that's being built meets the print and it meets the quality that we want it to have.
Fairway mower line does 100% audit on all the products that come off. Mitzi, our auditor, will come in and go through about an 8-page inspection sheet.
I probably know everything on that audit sheet without even looking at it. Torques, torque marks, loose hardware.
Paint quality is inspected from top to bottom.
All the safety decals. Any missed welds, hydraulic line, tie straps, harnesses, caution decals, information decals, hardware. We do safety tests.
She black lights the machine to look for any leaks. Pretty much every portion of the machine is inspected, not only by the operator after he completes the work, but by Mitzi after it's completed off the line.
Anything that doesn't look right, we question. When I audit a machine, I audit like I'm buying it. I work for the customer. I work for John Deere, but I work for the customer.
Our people out on the floor care. I've had people tear up on the lines. They are so concerned with customer satisfaction.
I don't like anything going out bad with my name on it and John Deere's, and it's not if I can help it.
We have generations of farmers that are still using John Deere equipment, and I imagine that in 3 or 4 more decades, we're going to see generations of golf course people using our equipment.
It comes down to sustainability. Quality is sustainability.
We're proud of our processes, we're proud of our people, but at the end of the day, we're most proud of our customers.
If it's got green on it, it's John Deere, John Deere's quality. John Deere's got the best of everybody that's worked on it.
When you watch the video on John Deere, my only concern with their quality was that they said they were very careful about not sending out a part that they would not buy themselves. Well, who defines quality? Is it the workers within the building? Is it the supervisor? Is it the manager? Is it the quality manager? No. Quality is defined from the customer. Well, however, back at John Deere, they are an original equipment manufacturer. So basically, they can set their quality standards themselves. So the customer defines quality. And the customer will let manufacturers know what their requirements are in terms of blueprints. Blueprint reading is a skill that I have rarely any skills in. However, if you are interested in learning more about blueprints, I know that Chippewa Valley Technical College, or WITC, has some short-term classes in that. The customer will also define their quality requirements by specific measurements. How long, how wide, how deep, and those measurements then are designed and printed on their blueprints. They will also give customers a list of statistical process control parameters. I'll show you in a slide a little bit later on in our presentation that will do a better job of explaining what SPC is. But then also, they may say, these are the visual checks we need you to do on this part. Visual checks. I know the older I get, the worse my visual checks get. And so if we only used our vision to check parts, we would potentially have about 80% defects in the parts that we are looking at. So this is a statistic that I'm going to give you a little exercise, and I'm going to prove to you this statistic. So 100% visual inspection typically results in only 80% perfection. Whoa. So if I visually checked 100 parts for specific defects, chances are about 20 of them will be defective and I may not even catch them. So here's a little paragraph. I want you to read it. And I'm only going to give you 10 to 15 seconds to read it. It's pretty short. And as you're reading this paragraph, I want you to count the number of F's and write down on a piece of paper the number of F's that you count. All right, how many F's did you get? Well, the average person gets about 3 or 4. And if you got 6, kudos for you. Put that on your resume. That's amazing. Because when we read, when we look at things, we skim. And so when you look at this paragraph, the F's that you may have missed, and I'll tell you where they all are: finished, and the word finished is an F. Files are the results of years of scientific study combined with the experience of years. The average person misses the ofs, and so as a result, if you got all 6, you would be an amazing inspector. So I've talked a little bit already about food manufacturing. Well, in our Chippewa community, Chippewa Falls, I should say, there is an amazing brewery called Leinenkugels. They have been in business for many, many years. And so I wanted to show you this video as it talks about their processes and quality at their brewery. If you haven't toured their facility, it's well worth the trip. But notice how important quality is to their brewery.
Discover the way beer is made in Wisconsin.
My 2 brothers and myself, we're now into the 6th generation of brewing here in Chippewa Falls, Wisconsin.
Jacob Leinenkugel, our great-great-grandfather, came here in 1867 because he found everything he needed to make his German lager-style beer.
He had access to the great water from the Big Eddy Springs. It's our most important critical ingredient.
Brewing beer is part science and part art.
We're still brewing Germanic styles of beer with an American twist.
A Summer Shandy is just a superb, very unique beer.
When people drink this beer, you can just watch it in their faces. They're going, wow.
When somebody's drinking a great tasting Leinenkugel's beer, they're getting over 6 generations of passion poured into each and every bottle that we take great pride in right here in Chippewa Falls, Wisconsin.
Discover.
Discover.
Discover
How we make great beer in Chippewa Falls, Wisconsin.
Discover more on Discovery.
I know, it's 5:30 someplace, right? But now we're going to not focus on beer from Leinenkugel's. I'm going to show you another amazing facility that manufactures food, and that's in our Eau Claire area, and that's Nestle's Food. Quality in food manufacturing is so critical. I'm going to let you watch this video, and they talk about in the Eau Claire location, they make baby formula. Well, if you've had a baby or are a grandparent or know of a baby, formula is critical. And for that formula to be perfect, to be flawless, is critical.
I am a quality control specialist in the microbiology labs.
My title is ingredient manager.
Formulation specialist.
I'm a quality control specialist, chemistry.
I am the laboratory manager here at the Eau Claire facility, and I manage the operations of our chemical, physical, and microbiological laboratories. We're a very well-respected laboratory within the Nestle world. We're a very large and very complicated factory lab. We have 55 employees in our laboratory. We have 22 currently working with Nestle Nutrition that are graduates of the UW Eau Claire Chemistry Department.
I think it means that we're doing the right things. We're teaching our students the right skills.
Some of the techniques we use in the lab here at Nestle, I learned how to do at UW Eau Claire. In the microbiology lab, we test all of the products that are made here at Nestle Nutrition in Eau Claire, which include baby formulas, the liquid kind, and powder.
I oversee all of the ingredients we use for the Nestle Nutrition and Nestle Health Science products.
And I am responsible mainly for the vitamin AE method. I test the vitamin A and vitamin E in the product that we produce and make sure it's where it needs to be.
I think this is just one example of how the university is preparing students, giving them the training and the skills that they need to hit the ground running in a job and be productive and useful workers.
I think the Eau Claire prepared me really well. I feel that I've been able to take exactly what I've learned, I guess, and really apply it.
I also think the LibEd, the liberal education experience here, also serves to kind of challenge our students and take them to the edge of their comfort zone.
I think it's important, the well-rounded liberal arts education.
Being able to talk in front of people, being able to write technically has been very strong skills that I directly learned from school that I apply daily.
I look at myself, and I finished a bachelor's degree, I finished a master's degree, and then within a year I was in a supervisory management type role. The core studies that you do contribute to rounding you out.
The link that we've established with Nestle proves that we are preparing students to be right out of the gate productive workers. We are sending students out who can contribute right away to the economic development in the state.
So I've showed you a couple of manufacturers as they talk about how important quality is in their processes. Yet how do the employees know what the quality standards are? How do they know how to do their jobs, especially when that job is as critical as food? So a lot of companies will use work instructions or work procedures. The company that I worked at, we implemented many tools of lean manufacturing, and the tool that we used to train our employees to was called standard work. So on the next slide, I'm going to give you an example of what a standard work document looks like. But on standard work, it will also point out where are the critical points, what point of that process or of that piece of device that you are manufacturing, what needs to be measured, what needs to be checked. It's going to give you step by step how to make the part. It's also going to tell you how long it should tell you to do that process. Standard work will also point out any safety concerns or any safety hazards to be aware of. It's also going to tell you how much material that you should have in your process. And it's going to show you with pictures how to produce this part. So when you look at the standard work slide, look at the green arrow under the part that says description. There's 7 steps to make this part, and it's clearly defined step by step. And also look over on the right-hand side of your document. It says critical points. Well, those are your quality checks. It clearly writes out what you need to check for to making sure that the proper bracket is orientated, that there's a pin in place and loaded down, that the collected cover is completely installed, having you check the weld quality. And then also note in red all of the safety concerns or safety pieces to be aware of. So standard work is one tool that many manufacturers use not only to help train their employees in safety and the procedure, but also what are the quality requirements for that process. Well, I'm going to talk briefly about tape measures. And of course, not all manufacturers use them, but many do. And if they don't, maybe this will be a good learning for a few things in your home. So using a tape measure, there are a few tricks that I want to share with you. In fact, the first one is with any tape measure, granted they're all different sizes and they are all different made of material, the cases are. This one is a 25-foot tape measure, and notice, what is this little metal piece for? And, oh, is it broken? It kind of moves around and jiggles on there. I'm not quite sure. When I put together the material for this presentation, one of my coworkers said, Bonnie, you need to tell people what that little metal piece is. His background was also manufacturing. He worked in manufacturing many years. He said it was very common for people to pull out their tape measure, get a little hammer, and knock down this little metal piece. Yikes, right? And so this little metal piece is meant to move. It actually, as you can see in this slide, it measures not only the outside diameter, you would hook it on the outside of a, and I'll just say even a table. So it could measure the outside or the inside diameter of whatever you're making or assembling. If this is damaged or missing, your measurement is not going to be accurate. I have a short video that I'd love for you to watch, and this woman clearly describes several different uses of the tape measure and what that little part is for.
Hi everybody, I'm Lee of CJ Drill, and today I want to show you a couple features on a tape measure that you may not have noticed, or maybe you did notice but you just didn't know what they're for. Come on in close and let me show you what I'm talking about. Now I have a few different tape measures here. It's 16 foot, I've got a 25 footer, a 12, and even a 6. One's metal and 3 are plastic, and I gotta tell you, it really doesn't matter. The features are all the same. So I'm going to pull the tape measure out, and the first thing you'll notice is there's a slot there. See that slot on the end? Well, it's not a design, it's actually a feature. And what it is it's a nail and screw grab. Let me show you how it works.
So there's our slot, right? Here's a nail. And what happens is you put that slot right over the nail and it secures the tape in place.
So if you're by yourself and you don't have someone to hold the other end of the tape, well, that nail grab there, it holds the tape for you. So you can make that measurement. You can use a screw or you can use a nail. It really just doesn't matter. It secures the tape. Now the next design feature is this serrated edge at the bottom of the hook. This is the hook here, and if you notice, it's serrated. Well, the reason for that is it's a scribing tool. Now what happens is a lot of times you're using a tape measure, right, and you don't have a pencil handy. Well, that scribing tool at the bottom of the hook will help you mark the material you're working on. What you do is you just want to scrape it back and forth like that, and so there's our mark. That's what we scribed. Okay, now I'm moving on to another feature, and I've got a different tape measure because it'll demonstrate it a little better than the other one. All these hooks, they move back and forth, and that's by design. Now, if you take a look at the first inch of the tape measure, you know what? It's not a full inch. Compare the first inch to the second inch. Well, the difference is, believe it or not, a 1/16 of an inch. The first inch of this tape measure is short by a 1/16 of an inch. So the thickness of this hook is a 1/16 of an inch. So when you make a measurement from an inside corner, it takes in consideration the space. So I'm going to place the tape measure on an outside edge, okay? Now I'm going to hold that hook in place so you can see it moving. So when you do an outside measurement, you pull taut on the tape measure. And what happens is it creates a space there, and that space is a 1/16 of an inch. And that 1/16 of an inch is created so that you get an accurate measurement. Okay, so at the base of every tape measure is a number. With this tape measure, it says 3 inches, and that tells us that the base is 3 inches in length. This tape measure also has millimeters here, so it's 76 millimeters. So the question is, why do they do that? Well, believe it or not, it makes it easy to make an inside measurement, and I'm going to show you exactly what I mean. Let me show you how this works, okay? Say you're making an inside measurement. I want to measure the inside of this window, right? Okay, so I've got my tape measure in place, right? But the bend of the tape measure distorts the reading, so it makes it really difficult to read. What the heck does that say? So what I have here is I have my tape measure in place. It's snug up against the wall. And what I'm going to do is I'm not going to rely just on the tape itself. I'm going to use the tape and the body of the tape measure, because we know that the base is 3 inches. From the top to the bottom here, that's 3 inches. So we add 3 inches to the 43 1/2 inches that's on the tape. We come up with 46 1/2 inches, and that's an accurate measurement. So hopefully I showed you a couple features, or a few features, on a tape measure maybe you didn't even know your tape measure had, right? Like that scribing tool. This is Leah saying you can do this. See you next time.
I'm going to give you a few tips on how to read a tape measure. And to be honest with you, if a tape measure is anything higher than a 1/16, I can't read it because it's too tiny. And from my experience in manufacturing, if a critical control point did need to be to the 30 seconds, chances are they're not going to be using a tape measure to do that measurement. So I have a handout for you, and on the handout it looks like a 1-inch measurement of a tape measure. It will have all of the lines in a 1/16 of an inch tape. And when you look at that, for those of you who are not familiar on how to read it, I always tell people, look for the longest lines first, because the longest line on any tape measure is going to indicate the inch. Well, most of the time it'll tell you 1 inch, 2 inch, but then the next longest line is the 1/2 inch. So if you're measuring, always look for where is the 1/2 inch mark. Pretty easy to pick up. The next longest line is actually the 1/4 of an inch. So when you look at your handout, you can follow along, and some of you may have a tape measure in your room with you, and if you do, please feel free to pick it up and work with it. Because the 1/8 of an inch, and this is where fractions come in. You're probably thinking, fractions? I thought we were talking about quality. Well, you need to understand fractions in order to understand a tape measure and what you're clearly reading. So, the 1/4 of an inch is the second longest line on your tape measure, and a 1/4 is the same as a quarter. We all like money, so when you think of a quarter, there are 4 quarters in a dollar. So there's 4 quarters in an inch. So clearly spend a couple seconds and look for that quarter mark on your tape measure. However, I'm going to show you now how to read it. So you would read 1/4, but you would not say 2/4, which is next. You have to break 2/4 down to your lowest common denominator, which is 1/2. And most of us get that piece of it. So 1/4 and 2/4, that's pretty easy to break down. So you have 1/4, 3/4, and then you have your inch. Now we're getting a little bit trickier, and now we're looking at the eighths. And so on your tape measure or on the handout that I gave you, look for the line that is indicated to be the next longest line, and it should be the second line in from the inch mark, and that's your 1/8 line. And so if you are having a hard time seeing with your handout, look on the slide. This is a blown up version of how to measure in 1/8. So we say 1/8, however, the next reading, we do not say 2/8. We say 1/8, 1/4, 3/8, and then there's our half, and we don't say 4/8, remember we say 1/2, and then 5/8, 7/8, and then 8/8 is the same as 1. I know this is a lot of fractions for people who haven't done this for a number of years, but hopefully with the handouts that I gave you today and a little bit of practice, you'll be just fine. So I'm not going to bring you to 30 seconds, but I am going to show you an example after we do the 16ths. So look at your tape measure again, or look at your handout, and now find the smallest mark on there. The smallest mark is a 16th. There are 16 marks between 0 and 1 inch. And so once again, we say 1/16, but we don't say 2/16. We break that down to the smallest fraction, which is 1/8. So 1/16, 3/16, 5/16, and then 7. And then of course, then there's our 8/16 at our half mark. So spend a little bit of time practicing your 16ths and you'll be just fine. This picture, however, shows what the 30 seconds look like. Maybe you can read it, but I can't. It is so, so small. But you may be lucky and have a tape measure, and they're called a cheater tape measure. I'm going to open mine up to see if it is. Oh, nope, it's not. And so a cheater tape measure, it will actually have the fractions written on the tape measure for you. Very nice. So if you have an option and you need to purchase one, look for tape measures that have the fractions written on them. I know with my last job in manufacturing, we did purchase tape measures with cheater fractions on for our employees. We felt it was more important to have them to be able to read the fractions versus them to have to sit and count and try to figure it out. I have a couple of worksheets that we are going to do together, and I want you to follow along. The first worksheet actually it's going to give you some practice in how to measure in 1/4 inch. So I'm going to bring my worksheet up for you so we both can be looking at the same thing. Most of you will probably be just fine with this one after you do a couple of the problems. But if you've not done fractions nor used a tape measure in several years, don't worry, the answers should be on either page 2 or on the back. So I'll have you take a couple of minutes, and the red line that you see on your screen or that you will see on your handout. On your handout, chances are it's gray because we don't have a colored printer, sorry. And for the first measurement, if you got 4 3/4, you did pretty well. Good job. And so take a few minutes now and write down the measurements for the other red bars on the remaining tape measure examples on your handout. The other handout that I have is very similar. However, this one is measuring in 1/16. So I'd like you to spend a few minutes now and answer the questions with the 1/16 worksheet, just as you did with the 1/4. But also remember, if you struggle, the answers are on the back. If any of this information is new to you or confusing, or if you know that you are going to need to learn how to use a tape measure for a job, I have another worksheet that's very detailed, very long, that may help you. And so if you'd like a copy of that, ask your case manager or just ask them at the job center. They can print that out for you. I decided to save a tree and not have it a part of your regular handouts, but I wanted you to know that it is available. Because to me, the best way to learn how to use a tape measure is just to practice, practice, and then practice with somebody who knows how to read one. So I've given you a little introduction to tape measures. So next we're going to talk about calipers. Calipers, to me, are much easier than a tape measure, especially the digital calipers. There are several different types of calipers, and however, this one, it has a readout, and so when you measure and use it correctly, it's going to tell you the measurement. And that's what I kind of like about using a caliper. Makes my job a little bit easier. However, the handheld calipers are not going to go out 25 feet. So they are good for the correct specifications, but not for the larger objects that we might have to measure. So when you're using a caliper, the first thing to do is to remember to keep it clean. In between the jaws or the openings, if it is not clean, it may actually get rust if it doesn't dry out completely after each use. So check out your teeth, your slide, making sure that it's clean and functioning correctly. The first step in using a tape measure, then after you know it's clean, is to turn it on and zero it out. I'm going to show you a little video here in a few minutes that's going to give you some step-by-step. So I'm going to show you how to turn it on, zero it out, but then also to change it from inches to millimeters. Aren't you happy that we still are reading in inches? However, if your employer is producing parts from Europe, those measurements may be in metrics. So that's the other nice thing about calipers. With a little push of a button, you can now read in metrics and or inches also. So this picture shows you how to place the part properly in between the jaws. You want to hold that caliper firmly, but not too firmly, and you want to make sure that you hold it not too lightly so that the part falls out. I wish I had a caliper at each location so that you could try and follow along with me, yet hopefully the handout that I'm going to give you is going to give you some good ideas and step-by-step how to use one. There's 3 different ways to use a caliper. You can use it to measure the outside dimensions of an item, the inside dimensions, and then also the depth of an object. So I'm going to let you watch this YouTube video, and she's going to give you some examples on how to measure those various dimensions.
This handy digital caliper measures in both inches and millimeters. To use the caliper, turn it on by pressing the red button or just slide it open. The yellow button resets the caliper to 0. Slide the caliper open to measure an article. You can toggle between millimeters and inches by pressing the green button. The measurement can be reset to 0 at any point to find the difference between sizes. Simply reset to 0 when you're done. Measure gemstones, settings, wire, metal thickness, and even inside diameters on items up to 100 millimeters or 4 inches with digital accuracy.
You can read a caliper by just reading the numbers that you see on that LCD screen, right? But what do all those numbers mean? If your reading is 1.1, what the heck is that 0.1? Well, this is another little math lesson. So when you're reading a caliper, you're actually reading decimals. And so if your 0.1 is tenths, The next two, anytime you get two numbers after that point, you're now reading 100ths. And then if you have three numbers after that point, you're now reading thousandths. So look at this screen, and it says the fraction equivalent of 0.1 or 1/10 is 1/10. So 100ths and 1,000ths. To me, it helps to equate those decimals to fractions because most of us are more practiced using fractions in our day-to-day life. I don't know about you, but I love to bake. And so fractions are as simple as, look at my measuring cups. You know, what is a half? Where's my 3/4? You know, where's my 1 cup? So if it helps, relate it to measuring recipes. So for those of you who like to build items, this is going to help you also. So reading the decimal, oftentimes, I also tell people, compare it to money. So on your caliper, if it says 0.1, it's the same as 1/10. 1/10 of a dollar is 10 cents. So when you write 10 cents, you write 0.10. It's the same as 10/100ths. So practice on your worksheets, read the number out loud, and then I also encourage you not only just to read it out loud, but to also write them out. And you might think, oh, this is really a pain, and which it might be. Yet if your job requires you to use a caliper, it's really important that you understand what you are reading. Because on this slide, where it talks about the rules of reading a decimals on a caliper, unless you are instructed, ignore that last number on the caliper. Because oftentimes it is going to read out 5 numbers. So in this example, it's 4.6785. You would ignore the 5. So you would read that 4 and 6,785 if you did not ignore that 5. So once again, I think it's important that you understand not only how to read it, but what you're reading. So read the number first, and then give it a label of the last space used. So for an example, 14.3, you would read that 14 and 3/10. 1.09 is 1 and 9/100ths. 3.021 is 3 and 21,000ths. So in manufacturing, I do have to be honest with you, we used to just say 3.021 instead of saying 3 and 21,000ths. Yet, which is absolutely fine and absolutely common to say the 3.021, yet I want to make sure that you understand what you're reading and understand that measurement as well. So decimals and calipers, they both are very basic tools, yet if you've not used one and you need to learn more how to use one, ask them at the Job Center. And once again, I have a handy dandy handout that you could take home with you, and I have some sample calipers also that we may be able to borrow you. So next quality term that we're going to talk about is statistical process control, or SPC. Now, SPC is a methodology where there are entire classes written to teach about SPC. When I went back to school as an adult, I feared math greatly. So you could probably hear me stumbling a little bit with fractions and decimals, and my worst class ever was statistics. The first day, the classroom was filled. I was so scared. I needed that class to graduate. I was an adult. I was a single mother with 3 kids. I needed to graduate fast so that I could earn a decent living. So with statistics, it is an entire history of numbers and processes, yet I'm not going to get into any of that. I just want you to know that when your company uses SPC, what you're going to need to know is that every process that there will be variations. And most variations are normal. But yet, if they have you track your readings, what you will be tracking is the variations in that process. And SPC will graphically depict when those normal variations become unnormal and you now have to do something about it. So with statistical process control, as you can see from this slide, there will be an upper control limit, or a UCL. So that's the largest that this part should be. There will be a center line, or a median, and then there'll be a lower control limit, or the lowest measurement that this part should be. And as you can see on this graph, that this process, or this part, has a lot of variation, and yet, looking at that line, it tells me it's normal. If your job requires you to know about SPC, the best place I can encourage you to go is to the internet. If you do a search on SPC, it is going to tell you anything you ever wanted to know. But I also know that our local technical colleges do have classes on statistical process control. Or you can go to Stout and take a class in statistics like I had to. I passed, but only the help of an amazing tutor. So statistical process control is going to tell you stability, predictability, and show you normal variations or special variations or special cause. So you think you know a lot about quality. Is 99% quality good enough? So if I had to measure 100 parts and one was bad, is that okay? Well, I'm going to show you this handout, and after we look at it, let me know if you think 99% quality is good enough. Statistics show that hospitals would give 12 newborns to the wrong parents every day if 99.9 was good enough. I just had a new granddaughter. I would be terrible. I would be so upset if they gave her to someone else. Is 99.9 good enough? Well, the United States Post Office would mishandle 18,322 pieces of mail every hour if 99.9 is good enough. The IRS would lose 2 million documents this year. Probably one of those might be your tax returns. The planes, 2 planes landing at Chicago O'Hare Airport would be unsafe every day. No wonder I don't like flying. I'm going to give you one more. Doctors would write 20,000 incorrect drug prescriptions this year if 99.9 is good enough. So think about that the next time that you are at work and they say, we need to have 100% of all of these parts meet the quality requirements of our customer. Hopefully that adds a little smile to your day and helps with the importance of quality in manufacturing. So the terminology that we talked about, I so encourage you to reference those terms the next time that you have a job interview in manufacturing, because they are going to ask you questions, and if you can give them the right answers, you're going to get the Kudos Award. There are some training options for you that in our area that may help you learn more. So the one that I found out about was at Chippewa Valley Technical School. They have a manufacturing quality certification. It's only a 17 credit class. The class does cost $2,200. However, you will get a certification in manufacturing quality. The topics include performing laboratory procedures. I think that would be super fun. Inspect products, measure process performance, how to record data, how to prepare formal reports, participate in quality improvement projects, and also you'll learn quality and lean fundamentals. I wish I could have taken that class when I worked in manufacturing. Another class in quality that Chippewa Valley Technical School offers is actually a food safety class. This too is a 17-credit class, and the topics include not only food safety regulations, but you'll get a hands-on opportunity to use some analysis tools and food microbiology, which I think would be super fun. And then also you would learn more about HACCP, the Hazard Control Analysis of Critical Control Points. So we've talked a lot about different quality tools, how to use a tape measure, how to use a caliper, and the importance of quality in manufacturing. When you look at the Help Wanted ads in the newspaper or on the Job Center of Wisconsin, I am sure you will see several openings in the field of quality. It is important in every job that we work at. However, especially in manufacturing and in healthcare, there are quality positions that are amazing positions. So I encourage you to look at the resources that I have given you from today's presentation. Decide if quality is a field that you may be interested in, and if so, I encourage you to check out your local technical college. I could not find a certificate program at WITC for those folks who are in our northern counties. However, they do have several classes that relate to quality. Well, I hope you enjoyed this presentation on quality in manufacturing. And if you have any questions at all, feel free to ask them at the Job Center. And thank you for attending.